So let us start the new chapter, permutations and combinations, today. Now permutations and combination chapter is really interesting chapter because most of the questions you can solve through your aptitude only. If you can think about these questions, then you can solve these questions, right? What we are going to study in this chapter is various ways to solve these questions even faster, and we will learn some formulae and learn some techniques to solve the questions based on permutations and combinations. Now before moving to permutations and combinations, let us understand how to count things smartly. So fundamental principle of counting. Fundamental principle of counting. This is what we are going to learn, and then we will move ahead. So fundamental principle of counting is a way to count things. Now if I ask you, let us say you have got shirt 1, shirt 2, you have got these 5 shirts. Okay, I am talking about shirts here. So these are all of different colors, for example black, blue, and so on. These are different color shirts, right? Now if I ask you how many ways, today you have got up and you are going to your office or school, then now I ask you how many ways can you wear a shirt, or today you have to wear a shirt, so what are the options that you have? How many options do you have? You will say 5 options. I can wear S1, this shirt, or this one, or this one, right? So there is an option here. There is an option with you. Or you can say there is sense of or, right? Now let me give you another situation. You have got 3 shirts, S1, S2, S3, and you have got 2 trousers, T1 and T2. Okay, and now if I ask you how many ways can you dress up, right? So you have to wear a shirt and a trouser, right? So if you wear shirt 1, you have options of wearing T1 or T2, right? Corresponding to this shirt you can wear trouser 1 or trouser 2. Similarly, if you wear S2, you can wear T1 or T2. So what are the options? You can dress up like this: S1 T1 or S1 T2, S2 T1, S2 T2. That is shirt S1 and trouser T1. So these are all different dresses, right? So if I ask you how many ways can you dress up, there are 6 ways that you can dress up, right? All of these 6 are different from each other, right? Either the shirt will be different or the trouser will be different. So when I'm saying that how many ways can you wear shirt and a trouser, now there is a sense of and, right? Earlier you had an option of wearing any of those 5 shirts, right? So we said there were five ways of wearing a shirt. Now you do not have an option, you have to wear a shirt and a trouser, right? So shirt, you have got 3 options. If I talk about only shirt, right, if I consider it event 1, right, E is for event. Event 1 is of wearing a shirt, so you got 3 ways. This event can happen in 3 ways. If I ask you to wear a trouser and call it event 2, this can happen in 2 ways, right? You can wear T1 or T2. But now when I am asking you to dress up, I mean E1 and E2 both should happen, right? E1 should happen and E2 should happen. So both happening, what are the number of ways that E1 E2 happens following E1 has happened, or vice versa? Then I'll say 3 into 2, 6 ways. Now I need to multiply these 3 and 2, right? Earlier what I did was I had 5 options, 1 plus 1 plus 1 plus, so I added those and got 5. So this is fundamental principle of counting, that if there is an event, let us say E1, can occur in m ways and E2 can occur in n ways, then number of ways E1 and E2 can occur will be equal to m into n ways. When I say E1 and E2, I mean one event following the other. Both of these events should happen. Let me take another example. I hope then it will be very simple for you to understand. For example, if you have to go from Delhi to Mumbai, now you have got following options. You can go through Shatabdi Express, right? You can choose Duronto Express. You have another option to travel by bus. Then you got another options to travel by your car. And let us take one more option. You may travel by an aeroplane. Now if I ask you in how many ways, these are the available options, okay? Now I am asking you in how many ways can you travel from Delhi to Mumbai? You will say either through this way or this way or this or this or this. So total 1, 2, 3, 4, 5 ways, right? Total 5 ways you can travel to Mumbai. So there was an option. Now I am putting a condition here. Now you have to travel from Delhi to Mumbai, right? And you have to go through Ahmedabad. Okay. So from Delhi to Ahmedabad, you can travel through this train, or let us say C1, your car, or bus. Okay. And then from Ahmedabad to Mumbai, you have got these ways, some T1, T2. Now these are modes of transport or routes that you can choose. So there is another way, that is you can use a car from Ahmedabad to Mumbai. Now if I ask you in how many ways can you travel from Delhi to Mumbai? Okay, how many ways? Now there is a condition that you have to go to Ahmedabad first, then you have to travel to Mumbai. You cannot go directly like the previous situation. So you can travel from Delhi to Mumbai in 4 ways, 1, 2, 3, 4, and from Ahmedabad to Mumbai in these 3 ways, right? Train 1, train 2, or C2. So now from Delhi to Mumbai you can travel total 4 into 3, 12 ways, right? If you notice, you can go from, let us say you go through road 1 from Delhi to Mumbai, or rail 1 Delhi to Ahmedabad, and then you have an option, right? Once you have reached through this way at Ahmedabad, now you have got 3 options corresponding to this, right? So corresponding to this also you will have 3 options, corresponding to this also you will have 3 options, corresponding to this also you will have 3 options of traveling from Ahmedabad to Mumbai. So if you see, corresponding to each way you traveled from Delhi to Ahmedabad, you have got 3 ways of traveling from Ahmedabad to Mumbai. So total there are 12 ways of traveling from Delhi to Mumbai now. So we multiplied number of ways of traveling from Delhi to Ahmedabad and number of ways of traveling from Ahmedabad to Mumbai. This is fundamental principle of counting. You can keep on counting it manually also. For example, one of the ways can be R1 T1, then R1 T2, R1 C2, right? These are the 3 possible scenarios when I go through R1. Now if I go through R2, so I'll have R2 T1, R2 T2, R2 C2, right? Similarly, 3 ways corresponding to this, 3 ways corresponding to this. So total 12 ways will be there. I hope you have understood the fundamental principle of counting, that if an event even can occur in m ways, and another event E2 can occur in n ways. Now these are two independent events. Delhi to Ahmedabad is an event, Ahmedabad to Mumbai is an event. But if I say, if an event E1 can occur in m ways, even another event E2 can occur in n ways, then E1 and E2 can occur in m into n ways. This is basically the statement of fundamental principle of counting. Now let us take 2-3 illustrations and you will understand what I am trying to say here. Let us consider this example first. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose. So you have got these 4 letters R-O-S-E, and you have to find number of 4-letter words, right? So you have to count 4-letter words where the repetition of letters is not allowed. So if I have to form a word, one of the words will be R-O-S-E, right? Now the word can be with or without a meaning. So I have another word starting with R, which can be R-O-E-S. This is another word. So we have to count all such 4-letter words that we can form. So starting with R, I can have another word R-E-O-S. Okay, so these are all the words that I want to count. Now what can be the smarter way to, now if I start listing these words, this will be very lengthy. So in mathematics we always find the shortest ways to solve problems, right? That is why the mathematics is useful. So now we need to find number of 4-letter words. So what essentially I've got here is, I've got 4 positions to fill, and I've got these letters to fill these positions with, right? So I can put any of these 4, 1, 2, 3, 4 here at this place. Let us say I put S. So at this place now, if I put S at the first place, now I've got 3 letters remaining here. So if I want to fill this place here, how many options do I have? When I was filling this place, I had 4 options, right? But now that I am filling this place here, how many options do I have with me? Let us say first place is filled with this letter S. So I've got only 3 options left. And there can be another scenario when the first place is filled by R, right? So there are 4 different ways to fill first place with me. Or you can start with any place. You can start with this place, this place. Okay, so first place that you choose to fill can be filled in 4 ways. That is, you can place R, O, S, E, any letter there at that place. Okay, now once you have filled one of the places, let us say we have filled this place with one of the words, then to fill the next place I'll have only 3 options left because I have already utilized one of the letters. So the second place can be filled with 3 different ways. And what about third place? Now you have utilized 2 letters. Let us say S, O we have already utilized. Okay, so the third place here can be filled in 2 ways. Okay, that is R or E. So if I fill R here, what are the number of ways I can fill this 4th place? Only 1, because R I have used, so this is the only option left, right? So this is one of the words that I have used to illustrate what I am trying to say, but these are the number of total words that can be formed like this, which is equal to 4 into 3, 12 into 2, 24 total words. 24 total words can be formed, which are 4-lettered words, with or without meaning, using only these 4 letters. Okay, let me do it once more. You have 4 places to fill, and you have got these letters to fill these places with. Now you cannot repeat a letter. Okay, now you start with any of the places. Let us say I start with this place here. Now how many options do I have to fill this place with? 1 2 3 4. Okay, now let us say I fill this place with R. Okay, now you choose any of the next places. If I choose this place, now I have utilized one of the letters already, so I have got 3 options left, right? So how many options did I have while filling this place? 4. While filling this place, now I have 3 options. For this, 2. For this, 1. Okay, so numbering is not important here because we will be forming all the words that are possible with these 4 letters. So to make it easy, you start with, let us say, first place. You can fill in 4 ways. All the letters are available. Now when you are filling the second place, one of the letters has already been utilized, so you have got 3 options, 2 options, 1 options, total 24 words you can form, because fundamental principle of counting says you need to multiply these. I hope this is enough explanation for you to understand fundamental principle of counting. And let us say we have got next example here. Given 4 flags of different colors, how many different signals can be generated if a signal requires use of 2 flags? So this is the situation. This is one of the flags and this is another flag. We have got 4 different flags. Okay, now this is one of the signals. This may be a combination. Let us say we have got a red color here and we have got a green color flag here. So this is one of the signals that you can form. You have got 4 flags of different colors. So 4 colors you have, and there are 2 positions that you need to fill, 1 2. Okay, so if you have got 4 options of filling the first position, first or second doesn't matter. If you start with here, you can call it first position. This depends on you. This is just to explain. You have got 4 different options to fill first position that you choose to fill. Okay, now once you have filled one of these, the second position can be filled only in 3 ways. Now one of the flags I have already utilized, so the second place can be filled with only 3 possible options. So first can be filled in 4 ways, second can be filled in 3 ways. Total number of different signals formed will be 4 into 3, that is 12 ways. That is 12 different signals can be generated using these flags of 4 different colors. Okay, you do it very slowly because these examples, NCERT has beautifully given the examples to make every student can understand, right? So whatever be your level of understanding, you can understand this entire chapter. NCERT has taken care of every student. So let us understand this example. How many 2-digit even numbers can be formed? Now we need to form 2-digit numbers. So we have basically 2 places to fill. Okay, what I mean is 2-digit numbers can be like this, 1 2 3 2. So we have got 2 places to fill to form a number, and we have got these 5 digits, 1 2 3 4 5 digits only to fill these 2 places with. Okay, now what is the given condition? That the number should be a 2-digit number and the number should be an even number. So for even number, the units place, that is this place, the units place should be occupied with an even number or multiple of 2. Either you should have 0, 2, 4, 6, 8, right? Apart from these, you cannot have any other digit at this units place because I need only 2-digit even numbers. Now 0 is not available, 8 is not available, 6 is not available because I need to choose from these options only, right? So how many ways can I fill this units place? Only 2 ways. What are those 2 ways? Either I can put 2 here or 4 here. These are the only 2 ways I can fill this units place, right? So units place can be filled in two ways, and this tens place can be filled in, digits can be repeated, right? So once you have filled this units place, you are not left with any lesser number of digits. You can still use, you can use any of these 5 digits at this place. What I am trying to say is this place can be filled in 5 ways because the repetition is allowed. So if you have filled 2 here, you are allowed to put 2 here. Repetition is allowed. So if you have utilized any of these 2 digits here, you will still have 1, 2, 3, 4, 5, these 5 options to fill this place with. So for example, if you have put 2 here or 4 here, so you can use 4 here, 2 here, you are allowed to do that. Or you can use 4 here, then any of the 5 digits you can place here, 1, 2, 3, 4, 5. So what are the numbers that will be formed? 12, 22, 32, 42, 52. All of these numbers are even numbers and 2 digit numbers. Similarly, if you have got 4 here, you may use 1, 2, 3, 4, 5, any of the digits here. So numbers will be 14, 24, 34, 44, 54. All of these numbers are allowed. So now total number of numbers, 2 digit numbers, even numbers will be 5 ways into 2 ways. That is 5 into 2, 10 ways. This is how we will be using fundamental principle of counting. I am explaining this in detail, but when we come to the exercise or when we understand what fundamental principle of counting is, I will be doing this really quickly because that is the purpose of learning this method. Otherwise, if you have to do it slowly, then you can count each and every case manually, right? For example, if this question is taken, find the number of different signals that can be generated by arranging at least. Now you have to notice, while doing this chapter, you have to apply your aptitude. Now it is at least 2 flags. This word, notice this word, at least 2 flags, okay, one below the another on a vertical staff. If 5 different flags are available, 5 different flags are available, right? And you can use at least 2 flags to generate a signal. Now at least means you can have 2 or 3 or 4 or 5 flags to generate a signal. At least 2 have to be taken, right? If I take at least 2, now this will be one of the signals. This can be different colors here. Okay, let us say one of the colors is this, another color is this. This is one of the signals, okay, where I have used only 2 flags because at least 2 flags have to be taken. So if I want this to be a signal, this will not be a signal. Now if I take 3 flags, one above the other, this is another way to generate a signal. So now we have got cases, at least 2 flags used, at least 2. So whenever you see at least, try to see, now this is the minimum number of flags that I want, so I can use more than these, right? So this is the least number. So what I'll do is I'll always try to convert at least or at most to exactly. So what are the options available with you? Either you can use exactly 2 flags, exactly 3 flags, exactly 4 flags, exactly 5 flags. Now tell me, what are the number of different signals that can be generated by at least 2 flags in order on vertical staff if 5 different flags are available? Now when you have exactly 2 flags, you need exactly 2 flags out of these 5. What will be the number of ways you can use that? You can fill any position within 5 ways. So the second position can be filled in 4 ways, because once you have filled one of the flags, right, one of the flags you have already posted here, so another flag which is just down, just below it, there are only 4 options available because you have used one of the flags. So you have got 4 flags, one of these can be used. So for the first flag you have got 5 options, for the second one you have got only 4 options. So in this case, when you use 2 flags, there will be 5 into 4, 20 different signals. But when you are using 3 flags, one above the another, first flag can be selected or chosen in 5 ways, another 4 ways, another 3 ways. Now, how many different signals can be generated? 60. When you have got exactly 4 flags, right, you have to generate signals using 4 flags out of 5. So first place can be filled in 5 ways, second in 4, third in 3, fourth in 2 ways, right? Once you have filled first place, you are left with 4 flags. Once you have filled second place, you are left with 3 flags. Okay, so total number of ways will be 5 into 4 into 3 into 2, that is 120. Okay, now when you have got exactly 5 flags, you need to place 5 flags like this, one above the another. 5 flags. So first can be placed in 5 ways, 4 ways, 3 ways, 2 ways, 1 ways. So this will also be equal to 120, right? So if I add these, whenever you have cases, when you form cases, right? So these are different cases, exactly 2, exactly 3, exactly 4, exactly 5. So you need to add these to find the total number of ways. So 20 plus 60 is 80, 80 plus 120 is 200, 200 plus 120 is 320 ways. Now these are 320 different signals that can be generated by arranging at least 2 flags, one below the another, out of these 5 different flags. I hope I am able to explain this to you and you have understood what fundamental principle of counting is. Let us move to the exercise now. I hope you have understood the way. Now we just do these questions really fast. So how many 3-digit numbers can be formed using these digits? First part is repetition of digits is allowed. So repetition allowed. What it means is we have to form 3-digit numbers. So we have got 3 places to fill and we have got these 5 digits. Okay, so repetition is allowed. So if I take any of these digits and place it here, so how many ways can I do that? I can do that in 5 ways. I can pick 1, 2, 3 or 4 or 5 and fill this place, right? So 5 different ways I can fill this place. Now what about this second place? Repetition of digits is allowed. So if I have filled first place with 3, I can use this 3 in second place also. So I still have got 5 options to fill the second place. Similarly, the third place can also be filled with any of these 5 because repetition is allowed. So these numbers are allowed. Let us say if I fill all these 3 positions with 2, this is a valid number. If I fill this 2 places with 2 and this with 3, this is a valid number. Repetition is allowed. Okay, so first place can be filled with 5 ways, second with 5 ways, third with also 5 ways. So total number of 3-digit numbers will be 5 into 5 into 5, that is 125 numbers. Okay, so the first answer to the first part is 125 such numbers will be formed. Now look at this, repetition of digits is not allowed. Now we need to form 3-digit numbers. If I fill first place or any of the places with any of these digits, so how many options do I have to fill this place? I've got 5 options, right? But now when I try to fill the other position, let us say this position, I have utilized one of the digits already and repetition is not allowed. So I have got only 4 options left to fill this place. What about the third one? Now I have utilized one digit here, one digit here out of these, right? So I am left with 3 options only. So I'll have 3 options to fill this place. So total number of words that can be, total number of numbers that can be formed will be 5 into 4 into 3, that is 60. This is how fundamental principle of counting helps us to count numbers in such a fast way. Otherwise, if you start counting it, these 3-digit numbers, you will have to count 60 different numbers, right? For example, 1 1 1, then 1 2 1, 1 2 2, and keep on counting like this, right? In the first place, when the repetition was allowed, you will have to count 125 numbers, and when the repetition is not allowed, you'll have to count 60 different numbers. Otherwise, if you just see this question, repetition is allowed, and you need to fill 3 places, so 5 into 5 into 5. This is how simple it is. Repetition is not allowed, so 5 into 4 into 3. This is 60. This is you can count them in 5 seconds using this fundamental principle of counting. Otherwise, it would have been very cumbersome process. So how many 3-digit even numbers can be formed? Now there is a condition. You need to pay rapt attention on the question. Now I need only even numbers. So it has restricted the number of ways I can fill this units place. Units place now can be filled only with 2, 4 or 6 out of these digits, because I need even numbers. Okay, rest of the places it is okay for me to fill with any of the digits, and the digits can be repeated. So to fill this place I have got 3 options. This place can be filled, or units place can be filled in 3 ways. And what are those ways? 2, 4 or 6. These are only 3 ways I can fill this units place. Now apart from units place, there is no restriction on this place or this place, because digits can be repeated. So I can fill this place with any of these 6 digits. That is 6 ways to fill this place and 6 ways to fill this place. So total number of 3-digit even numbers that I'll have is 6 into 6, 36 into 3, that is 108. Such numbers will be there. Digits can be repeated. Okay. How many 4-letter code can be formed using first 10 letters of English alphabet if no letter can be repeated? So I have to form a 4-letter code, 1, 2, 3, 4 places to be filled, and I have got 10 letters of English alphabet which are different from each other, right? So if I fill first place, I'll have 10 options. To fill second place, I'll have 9, 8, 7, right? Because no letter can be repeated. If I've used it here, I cannot use it here. So if I've used one of these 10 at this place, then I'll have only 9 options to fill this another place, and once I have filled these 2 letters, I'll have only 8 options left to fill the third one. I'll have only 7 options left to fill the fourth one. So the total number of options is 10 into 9 into 8 into 7. These are the number of 4-letter codes that can be formed. What is this number? This is 72 into 7, 5040. So these are the number of 4-letter codes that can be formed, right, using these letters. How many 5-digit telephone numbers can be constructed? So I have to fill 5 places, right? 1, 2, 3, 4, 5, right? So I need 5-digit phone numbers using the digits from 0 to 9. Okay. If each number starts with 67, so first 2 places I do not have any option apart from this. So I have to fill these first 2 places with these 2 numbers. So these 2 digits, I don't have any other option. So let me fill these places already. And no digit appears more than once. So it is also said that I cannot repeat the digits. I have utilized 2 of the digits from 0 to 9. How many total digits we have? We have got 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7. These are 10 digits that I have to use. Out of these, 2 digits are already fixed here. So I have to take care of only these 3 places to form these different telephone numbers. Okay. And I have to utilize out of these digits only 10 digits, out of which these 2 digits are utilized already. So to fill this place, how many options do I have? 2 digits have already been utilized. I have got total 10 digits. So I have got only 8 options to fill this third place. I have got only 7 options to fill this place. I have got only 6 options to fill this place, because no digit appears more than once. Okay. So total number of it. Now I have filled these places with 6 and 7. So what was the number of ways I can fill this place? Only one way. I can place 6 only. This place can be filled in only one way, that is 7 only, right? So these are the number of ways I can form these 5-digit telephone numbers, or these are the total number of telephone numbers, which is 6 sevens are 42 into 8, 336 numbers will be formed given these conditions. Okay. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? See, there is a coin. On one side of the coin I'll have heads, and on the other side I'll have tails, and it is tossed 3 times. So, and outcomes are recorded. How many possible outcomes are there? So first toss, what are the possible number of outcomes? 2 outcomes can be there. Either it can be head or it can be tails. Second toss, another 2 possible outcomes, heads and tails. Third toss, there will be 2 possible outcomes. Now, how many total possible outcomes are there? I'll say 2 into 2 into 2. That is 8 outcomes. Why do I say that? Because this is fundamental principle of counting, first of all. Otherwise, if you want to count manually and feel how fundamental principle of counting works, then what you can do is, you can take, at the first place, you can take heads. Okay, so there are 3 tosses. Okay, so let us say I've got 3 places to fill. Okay, first place can be filled with 2 ways. Either you can place H or T. Second place can be filled in 2 ways, H or T. Third place can be filled in 2 ways, H or T. So total number of ways to fill these 3 places will be 2 into 2 into 2, 8 ways. Still, if you want to count manually, you can do like this. You can place any one of these H or T here, then here and here. This is one of the ways. Then there can be another way when I've got H and T here. So you can keep on counting and you'll have 8 ways you can fill these places, or total number of outcomes that you can count. Okay. Given 5 different colors flags, how many different signals can be generated if each signal requires use of 2 flags, one below the another? This is a pretty simple question. We have done a more difficult question, you can say, in examples. I've got 5 flags of different colors, okay, and each signal requires use of 2 flags one over the another. So how many ways can I fill this one? 5 ways. How many ways can I fill this one? 4 ways. So what are the total number of signals that can be generated? 20 ways. 20 different signals. Because exactly 2 flags have to be used, right, one below the another, and you have got 5 options to choose from. So if you fill this place with 5 in 5 ways, you have options to fill the first place in 5 ways, then you'll be left with 4 flags to fill the second place. Or you can do it like this also. You can think about it like this also, that you can fill this place, or this, you can place a flag here in 5 ways. Then you'll have 4 different flags to fill this place. So 5 into 4 or 4 into 5 will give you 20 different signals. Okay, and it has covered all the possible signals that can be formed. So I think this was the exercise, right? Okay, thank you.